Hello everyone. Okay, so in this video we are looking at hypothesis testing. So, what is hypothesis testing? So, a hypothesis is a claim slash statement, right? So, a hypothesis would be 50% of girls in secondary school wore makeup this year, right? That is my statement. That's my hypothesis, right? So hypothesis, I think hypo is big and then thesis idea. So the big idea, right? That's the etymology of that word, right? So hypothesis is a claim slash statement. We often want to test these hypotheses. So we want to test hypotheses. And that's where hypothesis testing comes in. So to do this, we make an assumption, or my null hypothesis, and we offer an alternate hypothesis, which we call H1. So here's some examples of hypothesis and their corresponding alternate hypothesis. So my null hypothesis, the mean weight of adult men is 78 kg. Well, my alternate hypothesis would be the mean weight of adults is not 78 kg. 25% of dog owners have a crate. The percentage of dog owners who own a crate is not 25%. If the null hypothesis, the average marriage age of men is higher than the average marriage age of women. The alternate hypothesis would be the average marriage age of men is not higher than the average marriage age of women. So, how do we conduct a hypothesis test? How can we test such claims? So, we have to follow these steps here. And this continues on from the last video. So, first we do is, step 1, write down HO, so the null hypothesis. The null hypothesis, and H1, the alternate hypothesis. Step 2, we write down or calculate our sample proportion. Step 3, we find our margin of error, so 1 over root n, where n is my sample size. Then we write down the confidence interval for the population proportion P. So now we write down my confidence interval. So remember, my confidence interval stated I can make an interval of numbers where I'm 95% sure that my true actual population proportion lies. So this is the really important part. If the value of the population proportion stated is within the confidence interval, we fail to reject, right? So if someone claims 50% of girls wore makeup this year, right, and I did my study, I sampled some girls and I made my hypothesis, I made my confidence interval, and I found 50% it lies within this interval, I can't say we accept we can never say we accept a null hypothesis. The reason why we can never say we accept a null hypothesis is because we are only, with my interval here, we are only ever at most 95% confident. So that means we have a 5% chance of being wrong, right? So that's why we just say we fail to reject. We fail to reject it, right? We never say accept. We say, we fail to reject. We're always looking to fail or reject a null hypothesis. If the value is outside my interval, if the stated hypothesis is outside my confidence interval, we reject the null hypothesis. So, as I said, it's much easier for me just to do some questions and show you here. So, a student in a school claims 30% of parents drive a Range Rover. To test this claim, a group of statistics students carry out a survey. The results of the survey found 112 of 400 parents have a Range Rover and they've driven it to school. Write down the null hypothesis. So my null hypothesis, H0, is, so the population proportion is equal to 40%, where so 40%, not 30, so it's 30%. 30%, so there's my P there, 30% of parents, so it's 30, 30% of parents drive a Range Rover. Actually, let me write this down here. So 30% of parents drive a Range Rover. my alternate hypothesis. So part 2, write down my alternate hypothesis, right? So that means my population proportion is not 30%. So the percentage of parents who drive a Range Rover is not 30%. Right? So that's I. Let's look at the third part. Write down the sample size. Well, in my survey, what was my sample size? Well, it was 400. Gorge. Next, write down the margin of error. So margin of error is just 1 over root n. That's 1 over root 400, which is equal to 1 over 20, which is equal to 0.05. So my margin of error is 0.05. Calculate the sample proportion. So p hat. What proportion of my sample drove a Range Rover? Well, that was 112 out of 400. Which is equal to 0.28. Finally, calculate the confidence interval using this. So using p hat minus my margin of error and p hat plus my margin of error. So vi. So p hat, so give me the formula there. So it's going to be 0.28 minus 0.05 is less than my population proportion, which is less than 0.28 plus 0.05. 0.23 is less than p, which is less than 0.33. So I can say with 95% confidence between 0.23 and 0.33% of parents 0.33 parents drove a Range Rover. So writing this as percentage, that's just 23 and 33%. So now the ask is now part 5 or part VII. At a 95% confidence level, can we accept the student's claim? Right? Another way to get asked this, I said at a 95% confidence, they could say at 5% level of significance. Anyway, that's just doesn't matter. So can we accept the student's claim? So what was the student's claim? The student's claim here, so we have to look back up here. The student's claim that 30% of parents drove a Range Rover to school, right? Is that true? Well, looking for my sample, right, it lies within here. 30% is between 23% and 33%. So therefore, we can say so it's in my margin. So we are accepting the null, but we don't accept, we fail to reject. So we fail to reject the null as 30% lies within my interval. 30% of parents drive a Range Rover. And that's it. Alright? That's all you could be asked. So it's just one step more than what we're doing in the last video. So let's look at another one here. A school principal claimed that 50% of students were in favour of school uniform. The Students' Council carried out a survey of 120 students to test the claim. The results of the survey found 42 students were in favour of school uniform. So write down the null hypothesis. So H0, that is 50% of students were in favour, or are in favour, I should say, are in favour of uniform. My null my alternate hypothesis would be the percentage of students in favour of uniform is not 50%. Right, calculate the margin of error correct to 2 decimal places. Well, that is 1 over square root n. So what was my sample size? Well, they carried out a survey on 120 students. So that's my sample size there. So 1 over root 120. That is equal to, so it's 2 decimal places, so 0.09. So that is my margin of error there. What's the sample proportion? Well, what fraction of my sample were in favour of uniform? That's 42 were favour uniform out of 120. That is equal to 0.35. Calculate the confidence interval. So that is p hat minus my margin of error is less than my true population proportion. P hat plus my margin of error. So that is going to be 0.35 minus 0.09. 0.35 plus 0.09. And that is equal to 0.26 is less than p, which is less than 0.44. Right, or as percentages, that would be 26% and 44%. So I can say with 95% confidence between 26 and 44% of students are in favour of uniform. So let's conduct a hypothesis test on this claim. At 95% confidence interval, is this principal's claim correct? Is this principal's claim correct? So the principal claimed 50%. That was his claim. His claim was 50%. Is that correct? No, because it is not within this interval. 50% does not lie between 26 and 44. So therefore, we say we reject the null. We reject the null hypothesis as 50% does not lie in my interval, right? Therefore, then give a little statement at the end. Therefore, the percent of students who are in favor of uniform is not 50%. So I can say that with 95% confidence. Okay, let's look at some exam questions now. So this comes up literally, it comes up all the time. So we'll learn it. It comes up all the time. So, 2023. Last year, it came up last year, and give you another hint, it came up the year before, and I'll give you another hint, came up the year before that, and I'll give you another hint, I don't know 100%, but I'm pretty sure it came up the year before that. So we'll learn how to answer these questions. These are easy marks. So, a random sample of 500 students in Cork took a statistics test. 61 of these students were given a rating of excellent. So, question 1 is asking me here, work out the percentage of students in the sample who were given a rating of excellent. So, my sample proportion, so my proportion of my sample, p hat, is equal to, well, 61 out of 500 students got a score of excellent in the statistics test. And that is equal to 0.122, but it's asking me here work out the percentage, and that is going to be equal to change percentages, I multiply by 100, and that is going to be 12.2%, and that is my sample proportion there. Part 2, show that the margin of error of the sample is 4.5%, rounded to 2 decimal places. or 1 decimal place, I should say. So my margin of error is equal to 1 over root n equals 1 over root 500 students were in my survey. That is equal to 0.0447. Multiply that by 100. That to give me a percentage, that's going to give me 4.47%. But then it's asking me to round to 1 decimal place. So my answer is 4.5%. That is my margin of the error. So let's look at part 3. This is where my hypothesis test comes in. So in general, got something in my eye, sorry. I'll power through. Right. In general, 10% of students get a rating of excellent on the statistics test. Use your answer from BI and BII to test the claim that the percentage of students in Cork would get a rating of excellent is different from the population percentage at a 5% level of significance. So, my null hypothesis. We need to calculate my null and we need to calculate my alternate hypothesis. So, first of all, my null hypothesis is 10% of Cork students. Oh, in general. General, 10% of students get a rating of excellence. So 10% of students get a rating of excellence. Use answer from BI and BI to test the claim that the percentage of students in Cork would get a rating of excellence is different to the population percentage. So, then my alternate hypothesis here is the percentage of students the percentage of students who got excellent is not 10%. So, calculations, I need my confidence interval. So that is p hat minus my margin of error and p hat plus my margin of error. So 12.2% minus 4.5%. 12.2% plus 4.5%. So my margin of error is 7.7% and 16.7%. So that is my confidence interval there. So what conclusion can I draw here? My conclusion is, well, I'm claiming 10% of students get a rating of excellence, right? I want to claim, is this within my margin? Yes, it is. So it's within my, it's not my margin, sorry, it's within my interval. So we fail to reject. So I can say with 95% confidence, 10% of students do get a rating of excellence. So reason for the conclusion, 10% lies within my confidence interval. So we fail to reject. And that's it. Right, let's look at another exam question here. Again, 2022. So, the first part here is just a data sampling question. So, a survey was carried out to investigate the amount and type of exercise that adults in Ireland are taking in 2022. The survey is carried out on a sample of adults in Ireland. Write down one advantage and one disadvantage of carrying out a survey on a sample instead of a population. Right? Well, the advantage is cheaper. Probably should write that bit better. It's cheaper, faster, and it's more practical. Right? If I only have to test 50 people instead of like 100 people, like instead of like 200 people, why would I do that? It's cheaper. It's quicker. It's more practical because you can, like, you can't test an entire population. But a disadvantage is it's not as accurate as testing everybody. So testing like a small group of people is never going to be as good as testing the entire group of people. And then you could have sampling bias. So you could have sampling bias. So I could actually make a sample that is not really truly reflective of my population. So that is a disadvantage there. So section B though. A random sample of 1,500 people took part in a survey. Show that the margin of error for the survey is 2.6% correct to 1 decimal place. So margin of error equals 1 over root n. That equals 1 over root 1,500, which equals to 0.0. So 1 over root 1,500. That is equal to 0.0258 multiplied by 100% to get as a percentage. That's going to be 2.58%, but it says to 1 decimal place. So my margin of error is going to be equal to 2.6%. Right. Part 2. 71% of the sample say they walk for recreation. Find the number of people from the sample who said they walk for recreation. So 71% of the sample said they walk for... Sorry, I was misreading that. So 71% of the sample said they walk for recreation. Find the number of people from the sample who said they walk for recreation. So my sample was 1,500. I know 71% of them said they walk for recreation. So I just need to find 71% of 1,500. That's all they're asking here. So 1,500 times 71% equals 1,065, right? Or if you want to use your multipliers, 1,500 multiplied by 0.71, which equals to 1,065. Right. Use the percentages given in BI and BII. Write down a 95% confidence interval for the percentage of adults in Ireland who walk for recreation in 2022. So, sample proportion minus 1 over root n less than p less than sample proportion plus 1 over root n. So that is 71% minus 2.6%. 71% plus 2.6%. That's going to be 68.4% is less than P, which is less than 73.6%. So I can say with 95% confidence that between 68.4 and 73.6% of adults walk for recreation in 2022. So, but part IV is asking us here, according to a 2019 Irish Sports Monitor report, 65% of adults in Ireland walked for recreation. Carry out a hypothesis at a 5% level of significance. So remember, that's just another word for 95% confidence. To find out this figure, 65% has changed in 2022 based on the results of the above survey. Clearly state your conclusion and give a reason for your conclusion. So my null hypothesis equals, well, my population proportion is equal to 65% or 0.65, right? So my actual population proportion is still equal to 65%. So the percentage of people, 65% of adults, 65% of adults walk for recreation. then my null hypothesis would be it has changed. So my population portion is not equal to 65% anymore. So the percentage of adults who walk is not 65%. So, are we rejecting or failing to reject the null? Well, we are going to. So we have to look at a confidence interval. We reject the null. We reject the null. Why? What was the reason? To quote Cardi B, what was the reason? The reason is 65% is outside my interval. 65% does not lie between 68.4 and 73.6. So the reason is 65% does not, or 65% lies outside my confidence interval. So we reject the null hypothesis. So this is sufficient evidence to believe that the population proportion has changed. From 2019, right? And if you kind of think of it in a wider context, actually kind of does make sense. Like, we can say with 95% confidence that honestly that like the percentage of people who walk for recreation is more in 2022 than it is in 2019, because you know, like during like COVID and stuff like that, like in lockdowns and all that stuff, like people got into walking during I got into walking during COVID. So that does make sense that the percentage of people who walk for recreation has changed from 2019 to 2022. Right? Last question, two more questions. No, one more question. So, prior to the COVID-19 pandemic, Netflix held the largest share of online streaming markets. This is from 2021. Right, with 65% of all streaming subscribers between 15 and 65. AIM thought that this percentage might have changed during the pandemic and surveyed a sample of subscribers in this age group to get data. He carried out a hypothesis test to test his theory. So, if 500 people respond to a survey, calculate the margin of error of his survey, give your answer as percentage correct to 1%, or 1 decimal place. So my error is equal to 1 over root n equals 1 over root 540. That is going to be equal to 0.043 multiplied by 100%. That is going to give me 4.3%. So my margin of error is 4.3%. So, part 2. In his survey revealed that 372 of the respondents said they now have a Netflix account. Use your answer to part BI to create a 95% confidence interval. So, I need to get my sample proportion. So, what proportion of my sample said they have a Netflix account? Well, 372 out of 540 have a Netflix account now. So 372 all over 540. Which is equal to 0.68888, right? Multiplied by 100. Right, so that's going to be 0.69 multiplied by 100%. That's going to be roughly equal to 69%. So 69% of my sample have a Netflix account. Right, use your answer from BI to conduct a hypothesis test at a 5% level of significance to test Aidan's claim that the percentage of subscribers has changed. State clearly your null hypothesis and your alternate hypothesis. So, my null hypothesis is the population proportion is still 65%. So, remember the claim here, right? The online streaming market with 65% of subscribers between the ages of 15 and 65. So that's my claim here. The population proportion is still equal to 65%, right? So Netflix has 65% of all streaming subscribers from 15 to 65. And then my alternate hypothesis is, well, the population proportion does not equal 65% now. So it has changed to a value that's lower or higher. So Netflix, not Netflix, sorry. The percentage of subscribers the percentage of streamings the percentage of 15 to 65-year-olds who subscribe to Netflix is not 65% anymore, or has changed. So let's see what happens now. So my confidence interval, I haven't made it. So calculate my confidence interval now. So p hat minus 1 over root n less than p hat plus 1 over root n. So p hat, that is equal to 69%. 69%. And then my margin of error from part 1 is 4.3%. 69% plus 4.3%. That gives me 64.7% is less than P, which is less than 73.3%. So, looking at their claim, P is equal to 65%. And we're looking at my interval. What can we conclude? It's in my interval, so we fail to reject the null. So, there is insufficient evidence to believe that the percentage of subscribers to Netflix has changed. So, the percentage of subscribers to Netflix has not changed. So, with 95% confidence. So, with 95% confidence, the percentage of subscribers to Netflix has not changed. Sorry, my writing's a bit messy, but deal with it. Right, and that's all the exam questions there. So I'll make another video hopefully on some section B questions, statistics, like the bigger ones. But I hope this was some help to you, and I'll catch you guys later. Bye.